Okay, right, let's get started with today's session then. So hi everyone, welcome to our Advanced Data Science with Python training taster with Go Data Driven. It's great to have you all here. Happy Friday, everyone. We're gonna have a great 2 hours of doing some advanced data science work. So before we get started, I'll just do a little introduction about me, so you know who I am. So this is me. My name is Lucy Shepherd. My background, so where I come from, is I used to be a maths teacher, and I come from the UK. So I was a mathematics teacher for around 2 to 3 years. And then I decided that I wanted to go into a world where I actually could apply that mathematical skills. Felt like, I was always teaching the same topics. I wanted to expand on my knowledge. So I went into a UK bank, and I started doing some credit risk analysis there, building models to kind of see how much money we needed to set aside in case people couldn't repay mortgages, or whether we should give new lending to our customers, and also to detect potential fraud transactions within the bank. So we're sort of trying to protect people from these fraudulent transactions. I've been a trainer now in data science for 2 years, which is great. I managed to combine my two loves, teaching and sort of analysis and data science. So I've been a data science trainer for 2 years, and I joined Go Data Driven around 6 months ago, which is when I moved to the Netherlands, which is where I am right now. And then a small kind of personal fact about me, I try to think of something, and the only thing I can ever think is when someone asks what's a personal thing is, I like Harry Potter. And I even walked in today into the office listening to Harry Potter in my headphones. And I just repeat the books and read them again and again. I'm quite a big fan. And the image in the background is actually a computer generated book on Harry Potter. So someone, for some reason, decided that they had two passions in their life, which was machine learning and Harry Potter, and decided to combine these two things. And they made a predictive text generator from using all the previous Harry Potter books, and then wrote a new Harry Potter book using that generator. So if you want to have a look at that, I'll drop the link in the chat so you can have a look. You can also create your own book. You can write it. It's an online generator. You can write your own novel in Harry Potter, but it's actually pretty good. It's actually a pretty good book. I was pretty impressed when I found that. So that's a little bit about me. I'm just going to switch over what I'm sharing. Should be that one. Let me just do this one more time. Always want to make sure I'm sharing the right screen. Lovely, that's it. Okay, so if you have managed to download the files, or you're on the binder link, you should see something that looks very similar to this. So we've got our different folders. We've got two IPython notebook files, and those are what we're going to use today throughout the training. And I'm just going to click on into the introduction. And this is set up as a presentation. So I'm going to run this as a presentation. If you are within Binder or you have Rise downloaded, you'll be able to automatically have this as a presentation. So let me just get myself set up. I wanted to be able to see the chat. And I'll just pop that in the chat. So Rise is a package or an add-on that you can have with Jupyter Notebook. And it gives you this button up here to present as a presentation, which I actually skipped to the end, which is not what I want. Okay, so today, we've got 2 hours today to do some advanced data science with Python. That's not a lot of time. Usually we have 2 days to cover a lot more topics. I'll talk about what topics we do cover, and I'll talk a little bit about what we're going to cover in today's session. We really cover all different kinds of aspects of advanced machine learning, really different tools and techniques that are really going to help you enhance your model development. We also look a little bit at unsupervised learning, so an advanced sort of machine learning topic, unsupervised. Today, I've just picked one topic for us to really focus on, because there's no point trying to squeeze all those 2 days into 2 hours, because we're not going to be able to go quite deep. What I wanted to do is just pick one topic that I think was quite great from our course. It really helps you go to the next level with your machine learning, and that is with feature engineering. Because this is an advanced course, we do have a few prerequisites for the course. They're not like hard prerequisites. We don't mind if you haven't got this background, but it's really useful if you're really comfortable with the following 3 things. So building a model using scikit-learn. We use scikit-learn throughout our courses. We have a course that goes before this, which is called Certified Data Science with Python. All these links are going to be available at the end. And we cover scikit-learn in that, and then we just build upon that within this training. If you have backgrounds in other kinds of machine learning, that is fine. If you kind of have an idea what those algorithms are all about, for you to really get the most out of this training. Because we're doing scikit-learn, we also talk about scikit-learn pipelines. Again, we want that something to be pretty comfortable with. In this 2 hours, we're going to see scikit-learn and we're going to see scikit-learn pipelines. I'm not going to go into depth to explaining them. So if you're not familiar with them, yeah, follow along with today and see what we do, see how we use it. And then maybe come back to the code and really sort of look into it and then learn it on your own time and think, oh, you know, how can I learn a little bit more about this? And then finally, using pipelines in pandas. This is my favorite topic. I am like, I love pandas. I'm everything pandas. And we use pipelines, and today I'll be using a lot of pipelines in pandas, and I'll talk a little bit about what that means when we get to it. But if you can do pandas chaining, or you're just more comfortable with the pandas library, then yeah, that's pretty good. That's enough. So today we have 2 hours. We have a taster. There will be exercises. So I know this is a taster. People often think it will just be a presentation. No, that's not how it will be. This is a training taster. So emphasis on the training, emphasis on you are the participants. Want you to get the most out of this. So there will be exercises and code alongs for you to do. So if you haven't already, visit one of those links in the chat and follow along with us. Okay, so if there's some exercises, have a go at it. If there's some code along, yeah, have a go. Change different things, change different parameters and see how that affects the code. And this is your learning journey today. I'm just really here to guide. It's not really about me, it's about you guys. That being said, I've done an introduction to myself and to the course. I'd like to learn a little bit about who we've got in the room. So different exercises mainly we'll use the chat. So if you've got questions or if you've got answers that you want to share, you can drop things in the chat. If you want to be a little bit brave and come off mute, feel free to do that, interrupt me. I'm absolutely happy with people doing that. I know it's a little bit trickier because we don't have 2 days together, so we might not know each other as much as we do on a training course, but you know, if you want to do that, feel free. But another way we'll just do exercises and get to know each other is through polls. So I'm going to generate a poll in Zoom, and you'll see 3 questions. So I just want to know a little bit about who we have on the course. So first of all, you know, how much experience do you have in the world of data science? So what kind of experience are you bringing here? We usually get a range of this, so I'm just sort of, there's no correct answer here. And then what type of machine learning is your favorite? So it might not be your favorite, but it might be what you're currently working. So do you predict continuous features of continuous values, or do you predict classes? Yes, no, fraud, not fraud. And yeah, anything else. I mean, if you haven't got anything, if you say nothing yet, maybe you want to be inspired today, yeah, let me know. And then if you have a superhero name, what's that? So just a little bit of fun, like what, I want to know what kind of people we have in here. And you'll notice they're all very similar to Marvel characters, but I've changed them slightly. So if anyone from Marvel has joined the call, they're not gonna sue us for copyright. Lovely, okay. And then once you've answered those questions, make sure you hit submit at the end, otherwise we won't see them, but I'm seeing a lot of answers coming into the chat, into the poll. Lovely, so I can see 18 people have voted, nice. So let me give you a few more seconds to finish that up, maybe about 20 more seconds to finish up. Okay, I'll give you 5 more seconds. So if you haven't already, hit on submit so we can see your answers, and then I'll share the poll with everyone. Okay. Okay, let me share these results so you can see what we have going on. So the red just really means that's the majority. So you can see we've got people with up to kind of 2 years experience, the majority. We've got a few people with further experience. So if you have anything to add that you want to add for the people with who are sort of a bit more new to it, yeah, feel free to sort of add that into the chat or come off mute and say to us what your experience is so we can learn from you as well. I always learn in my training as much as I teach. That's one of the reasons I love trainings, because I'm always learning from the people we have in the training. Favorite type of machine learning, classification is the biggest one here, but a few people doing sort of more continuous values, so regression, some people who love clustering, lovely. Reinforcement learning, yeah, that's where it's at. Some deep learning. So one person with likes deep learning, one person loves images and text. So we have courses that are specifically on these two different things. We're not going to cover that in this course, but if you are interested in that, yeah, definitely have a look at what courses we have with that, because that might be something that really tickles your taste buds. And then a few people that are just here to be inspired. So yeah, let's hope we do some inspiration here. And then superheroes. We've got, well, majority of us are swimmers, aqua soldiers, few healthy people, so 5 people are meager power, yeah, and then yeah, kind of mixed from the rest, the general mix. And then one person said other, so I'm really interested to know what your superhero name is. If it wasn't listed, you can drop that into the chat, and we'll see what your superhero name is. Please do let us know. I'm very, very intrigued. Or maybe it was a slip and you're actually you're also an aqua soldier. Okay, cool. So that is an example of what sort of thing we're going to be using throughout today. There'll be a few more polls, either way, to answer questions or just get on with exercises. We'll be using them throughout. So hopefully you're now comfortable with how that looks and how you're experiencing that. Right. So let's get into the hot topics. So with all our advanced training, because we often get people from different backgrounds, we want to make sure everyone is starting from the same place. So I'm just going to go through a kind of a quick refresher on machine learning, just so everyone's comfortable before we get into the more advanced topics. It's very short, but it's just going to help kind of remind us of where we are. So let me just find my button to move forward. Got so many different windows open. Okay, perfect. So machine learning. Machine learning, it's really that buzzword, hear it a lot. And it's very much talked about, especially with the high amount of data that has been made over the past few years. It's exponential growth of data. Something like 90% of the world's data was created in the last 2 years. I think that's crazy. That's like so much data, and 10% all the way before it. It really is this sort of ever increasing bank of information. So yeah, of course, machine learning is becoming such a big thing. Really used, to automate mundane tasks or just offer some insight. Different types, we've already talked a little bit about this with that question in the poll, but we might be doing something like prediction. So just using the past data that we have and then seeing if we can find some trends in that to then predict what's going to happen within the future. Maybe it's image recognition. So maybe you're unlocking your phone and your phone can recognize who you are. Or maybe we're trying to detect potential fraudsters. So if someone comes in with an ID and we run it through the system, we say, actually, no, that face come up so many different times. Maybe we want to flag that. Speech recognition, this is the one I have the biggest bugbear with. My Google Home never recognizes me. She does, she just pretends she doesn't. I say, okay, Google, and she doesn't do anything. And my boyfriend comes along, says, okay, Google, and she lights up and she starts talking. It's one of my biggest bugbears. But maybe it's something like recognizing speech, maybe translating the spoken speech into a different language. Medical diagnoses. So we actually have someone within Go Data Driven, another trainer, who actually comes from this background, looking at imagery to try and recognize diseases and try and spot diseases. Or maybe it's a really big part of machine learning, or a really big section of it is financial industry. Can we predict stock prices? I mean, if we could do that 100% correctly, lots of people would be very happy. Maybe people wouldn't be sort of stuck in this down, this dip at the moment with all the Bitcoin and online currencies. Or maybe it's sort of doing something like what I come from, credit checks, trying to understand what people are like, whether we should trust that they're going to be able to pay something back if we give them some money. So a quick history. I think it's always nice to go through a quick history and understand where we've come from. So the first computer system, the first manually operated computer system, was called the ENIAC. and it was made in the 40s. And it was actually named after humans, because humans were the computers. They were doing really big computation, it had really big computation capabilities, and they wanted to try and replicate this in the machine. You might be thinking this is, well, that's just really a big calculator. Doesn't really have anything to do with machine learning. And I would say that's wrong, because actually this machine was created, and then afterwards it started getting better and better, and humans were actually able to learn from the ENIAC machine. And that's kind of this huge thing of actually creating something that learns from us, because we've created it in the first place, but then we can learn from it because it learns different things, and then we learn from its own experience. And then what happened after that? So there was this big development. In the 50s, artificial intelligence became a bigger thing. So the first computer game that could beat the world checkers champion, I mean, there's a bit of controversy whether this could actually beat the checkers champion, but someone claimed, this can beat the best checkers world champion. And actually what happened, again, people were using this to then improve their skills in checkers. And then thanks to statistics in the sort of 80s, 90s, machine learning gave birth. And really, the intersection of computer science and statistics really gave birth to all these different kinds of approaches in AI. And this shifted the field further towards this data-driven approach that we see in so many different places. And having this large-scale data available, I mentioned about having so much data created in the last 2 years, scientists really started to build intelligent systems that were able to analyze and learn from all this massive amount of data that we have. So what really is machine learning? Well, simply put, it's an algorithm that enables a computer to learn from data and even improve themselves without human intervention, without us sort of explicitly saying what they need to do. 3 different types of algorithms. I love this image. It's not my image. I really wish it was, because I think it's super. I think it really explains it really well. But on the left-hand side, we've got supervised learning. Supervised is where you have data that's completely labeled. So you're saying to this robot, this is what a cube looks like. Look out for these key characteristics. And then you give it something that says, okay, I understand this looks like a cube. So that's our supervised. In the middle, we have unsupervised. So you're just saying, okay, robot, here are loads of different shapes. What can you do with this? And the robot says, well, these kind of look different to these, so they must be separate. These are related, these are related, so these must be separate. So I'm saying, okay, those must be groups. And then the last one is the reinforcement learning. We don't really cover that in our training because it's a little bit of a niche, but really what we're doing is we're putting this robot into an environment and saying, have at it, do what you will, have fun, and we'll give you loads of different things to do, and just see what you can do, see what you learn from it. And it gets rewards, and then it gets, bad things happen, and it says, okay, I won't do that again. And then it learns to get better and better in that way. Some consider this semi-supervised to be the 4th type of algorithm, where you have some labeled, some unlabeled. So you have some information about these squares, but you maybe don't give any information about the cylinders. So you have to do a mixture of different techniques. I kind of don't consider it the 4th type because it's just a combination of 2 different things. But some people often say there's 4. A little overview of those 3 then, a little bit deeper. So the thing we're going to look at today is a regression problem. And regression is really where you're looking at some kind of output variable which is continuous. So maybe it's something like dollars, house price, or weight, the weight of, we do this in our training, the weight of chickens. We try and predict the weight of the chicken, how that's going to look over time. Are we going to be able to, for a farmer, are we going to be able to get the weight we need for our chickens? Or it's, we're looking at classification where we say we have some green dots, we have some maybe, I guess that's like a blue or a teal. Where can we split this so that we kind of get the majority of the blue and the majority of the green? And the key thing here is that we have these labeled examples. So at some point we know what's green and blue. We may not know it today, but we'll know it in 3 months' time. So if we go back 3 months, we'll be able to use data that knew what it was, and we can maybe make some understanding about the different trends, and then look at the data we have today and say, okay, from what we saw 3 months ago, I can now assume what I'm going to have in 3 months' time. So that's our first step. We have to have labeled data. Then we have to pick a model and find the optimal model parameters, and then we use that model to predict our unknown labels. So we have known, We use that to predict an unknown. How does this differ from unsupervised then? Well, unsupervised, like I said, we have a collection of things, but we don't tell it, this is what a duck looks like, this is what a rabbit looks like, this is what a mouse looks like. I mean, they are not what a mouse looks like, I don't think. But the unsupervised learning says, oh, okay, these kind of look similar and these look similar. So there's no real corresponding output. The computer, the machine that we've got creates this output for us. So really what we're doing is we're modeling the underlying structure or distribution. And there's no real correct answer. There's no teacher. There's no one that says, okay, yeah, you put Donald and Daffy together and that makes sense. Well done. So it's a little bit harder to measure in that way. And we talk about that during the course, about how you can see if your model's doing well. And then, yeah, it's kind of left on its own to discover the structure. We don't mother it. We don't support it throughout that. It discovers the structure by itself. So different types that we have, we talk about clustering within the training in the 2 days. We're not going to cover it today, but we do in our 2-day training, because it's nice to look at some advanced techniques in a more advanced machine learning type problem. And it's really where you kind of discover these inherent groupings of the data. So we might say here in our unsupervised, in our example, create 3 groups. And it says, okay, I'm creating 3 groups. Well, these are group, this is a group, this is a group. And it kind of builds from there. Association is a little bit different. And it's a kind of learning problem or a learning rule that kind of looks at large portions of a data. So this kind of key thing, or where I see it the most, is on Netflix, where it says, okay, you've watched Love is Blind. You probably want to watch now Who is the One, or that program. My boyfriend loves those kind of shows. And he said that last night, actually, we're not watching a reality show at the moment. And he said it like it was a really big problem. And I was like, yeah, that's good. That's a really good thing. But I'm sure he's going to have picked a program for us to watch when I get home tonight, I'm sure. But yeah, all that kind of suggestion. Customers also watched this, so maybe you want to go and watch this. That's the association. So that's unsupervised. So the last one was that reinforcement learning. So it's taking this kind of agent, putting in an environment, saying, do some actions and learn from it. So, okay, right, if I take this action, I get something good or I get something bad. So I understand what I need to do. I learn what I need to do from that. Examples of reinforcement learning. Well, the difference between these top 2 is that you could build a model for chess that would just say, okay, if you take all these different combinations, you have millions of different combinations that you might be able to take in chess. And then you can say, okay, if you take all these, then you're going to win. And depending on what the other person plays, you're going to win or you're going to lose. But there's this game called Go. And if you've heard of it, maybe you've watched AlphaGo on Netflix. Again, mentioning Netflix a lot because it's a huge part of my life in lockdown. But I recommend it, AlphaGo. It's a really good documentary. And it's all about this computer that learns to play the game Go. And you can't say the same as chess. You can't say these are different combinations that you're going to have, because there are beyond millions. There's millions of millions. And there's just way too many for a computer to be able to actually compute all of those to know what move to take, because there's just so many different options. So they had to build something that thought like a human and had these different neural networks, like in our brain, that learned how to play this game. And like I say, it's a very interesting game in itself, and it's a very interesting documentary, and understanding how that computer learns, it was so good. And then another thing as well is Dota. I don't know if anyone plays Dota, but it's, again, another lockdown hobby of mine, which I've picked up. I'm terrible, so if you do want to play, don't play with me. And this is a very complicated game. I'm terrible at it because you have to be so fast on reactions. You have to know what kind of items you need to buy. If you're a wizard, you need to know that a magic staff is going to be really helpful to you, but boots are, certain kind of boots. It's so deep and difficult. And OpenAI actually managed to build a computer that could play Dota and could understand the different nuances between the characters and understand how to play it. And it actually ended up beating some of the world champions in Dota. Again, if you're interested in this kind of area, which I think one person said they were, this is their jam, definitely check these things out if you haven't already. So in summary, we have these 3 different types of algorithms: supervised, unsupervised, and reinforcements. We are going to be looking at supervised, and because like we saw in the poll, most people come from this world of supervised. So we want to be able to give you tools and techniques that are going to help you build and make things even better in the world of supervised learning. And yeah, it's also, it's good to know about the other two. It's good to know about unsupervised. We do cover this in the long training, but we will not today. And we don't cover this today because it's its own topic in itself. It's so big. So what do we focus on in the course? We cover off what machine learning is, just like I've done with you today. And then we talk about how you can choose the right model. So how do you know if it's supervised, unsupervised, if it's classification or regression? And then from there, which algorithm do you even choose? Then we talk about feature engineering, which we'll cover today, we look at today. We also talk about feature selection. So now, once you've engineered features and you have loads of features, how do you actually choose which ones you use? Because do you want to use 1,000, 2,000 features? Probably not. So how do you select the right ones? Unsupervised learning. So we talk about clustering in the training, say not today. But we also cover off advanced Python, which I think people don't often think of when they think of advanced data science. But it's advanced data science with Python. You need to be able to do really good Python to get your machine learning to be the next level. And this is, again, one of my kind of favorite areas is really kind of improving Python and having these coding best practices. So we talk about object-oriented programming, we talk about functional programming, the differences between them. This one's really good to understand because scikit-learn's all object-oriented. So if you understand object-oriented programming, you understand scikit-learn, you can make your own objects in scikit-learn, your own estimators, your own models, your own transformers in scikit-learn to go to the next level. So you do some kind of really niche thing that you need to do. And then finally, we talk about how do you put this in production? Because once you've got it there, it's kind of nothing unless you can put it into production. So we talk about how you can do that. We also talk about Streamlit, which if you don't know about it, I definitely recommend just having a look and seeing what that's all about. And obviously, we want you to be able to practice this. So we have a hackathon, some way for you to actually apply these skills. Everything in bold, we touch upon today. We either cover them in depth, like the feature engineering, or we touch upon them in today's taster. So that is our setup. That is how, everyone should now kind of be in the same place. We should be feeling kind of, yes, I'm ready to go into the advanced topics now. So let's do that. Let's take a look at our main topic of this taster. So we're going to go ahead and go into the feature engineering notebook. So you can either click at it from here or just back in the main section. It's just our next notebook, number 1, feature engineering. And it should look something like this. So I'll give you a bit of time just to get that open. Okay. So feature engineering, an example with bikes. Okay. So the success of any kind of machine learning algorithm, it's not just the algorithm. We can't just I remember my first ever hackathon I went to back when the world was a little bit more open. I went to this event and we were there to build a model, and all these kind of people, fresh faces, fresh to the world of data science, they said, here's the data. And they said, okay, let's just put it into the model. Let's just get a random forest and let's just shove this data into the model. And I mean, the model wasn't actually that bad, but it could be so much better. It could be so much better because you need to clean the data. You need to inspect the data. Really, as a human, you need to understand what this data is telling you just as much as the machine does, or maybe not just as much because the machine is very intelligent. You need to understand it a little bit just in case you're doing something really ethically wrong, or your model's really picking up on something that's actually doesn't make any logical sense, but just because you've got that subset of data, it's kind of learned something really weird. You need to know much more about it than just saying, just put it in the model, and let the model do the work. And one of those things that you might want to do within the cleaning step is give it more power, or give it more features to really pull out some of the key bits of information. And that's what feature engineering is all about. We have different pre-processing techniques, which we'll look at today. The main one we'll look at is one-hot encoding. So if you have categorical data, scikit-learn can't really understand that. So you have to do some kind of one-hot encoding or label encoding to transform that into numeric data. Some kind of data cleaning you might need to look at is missing data. Again, because scikit-learn can't really handle that. So you need to think about how do I impute this? Do I just remove them? Or do I learn from it in some kind of way? And then you might need to scale or normalize your data. These steps this step of scaling and normalizing missing data and removing or imputing will be used, and as well as hot encoding. So I'm not going to go into them in depth, but you will see them throughout the notebook. I've just seen a question in chat, do we have this? Yes, you'll get a recording of this after the training. We've got it on record. And then if you want to have a look at the notebooks again, I'll just put that link in the chat. So everyone. You can go onto there, onto Binder, and it will open up these notebooks. So you can download it straight from there, or you can download it from GitHub. The link is also available in Binder to the GitHub. Okay, so this notebook then, what we're going to cover. We'll look at the data, first of all. Like I just said, it's really important to understand that data. We'll build a baseline model. So kind of what I just said, like those people that I met in that hackathon, let's just throw it into the model and see what happens. And then we'll do some feature engineering and see if that can improve our model. So we have a date. We're going to create some features around the date. We're going to infer some features, so looking at past data. And then we'll also look at different types of encoding. So I've mentioned one-hot encoding. I mentioned label encoding. One thing that people don't normally look at is mean encoding. So we'll look at that as well. This is not exhaustive. There are way more different types of feature engineering. So we'll talk a little bit about different types. Again, even that list isn't exhaustive. There's loads of different ways to engineer features. And then we'll just round it off with concluding everything together and what you can do next. What can you do next to carry on this learning or actually kind of implement it? So before we do anything, we have to load in our libraries, everything that we'll need. It's just in here. So I'm just going to go ahead and run this. If you haven't used Jupyter Notebook before, you can just hit run at the top. Or you can do Control and Enter, and it will run. And then we see it goes from a star, and now it says 1 because it's run, the first thing that's run. Let's keep going. So about the data. So we're looking at this capital bike share system. So we have some data about different bike rentals between the years 2011 and 2012. We have the hourly and the daily counts of these different rentals. It also includes some data corresponding to weather and seasonal information, which I imagine is quite impactful. If it's a nice sunny day, people are probably more likely to want to go out on the bike. If it's snowing and horizontal winds, unless you're in the Netherlands where there's just no stopping people on bikes, you're probably not likely to want to hire a bike. So let's take a look at this data. So I'm just going to read this in. I'm going to run this and have a look at this. So first few things, I'm passing these dates because I have a date time. I want to have it as my index. So whenever we're working with some kind of time series, this is time series because every new entry is a bit further on in the data. First thing I'm going to do is always put this as my date, the date time as my index. I'm going to have a date time index. If I have a look at the index, it tells me it's a date time index because it's very powerful to have. And there's different reasons for that, and we'll see that in the next step. And then I have this information about the weather, so different things about the weather, the humidity, the temperature, the speed of the wind. And then I have this variable CNT, so the count of how many bikes within that hour on that day, how many bikes were hired. That's quite a lot for the very first hour of the year. I guess maybe it's the end of the beginning of the year, it's the end of New Year's Eve, maybe people are needing to get home. And this is in America as well, so that's maybe important to note because this would be a holiday in America. So I'm going to give you some time now to get to know this data. Instead of me just describing everything to you, 4 questions, and I'll put these up in a poll for you to answer as well. Can we understand how many missing values are there in the data? What's the earliest and latest date? So can we use the minimax to get that data? What's the mean of the humidity? And can we do that by year? So can we maybe do a group by and find the mean for each year? And then finally a plot. This is where date time indexes become really, really useful. And the amount of times I've seen people not do a date time index as their x-axis in the plot is too many. Let's keep it as a date time index and plot it. And see if we can plot the count over time. If you can do extra, if you want to do extra, group it by the month so that it's a bit smoother, so we don't see every single hour on a graph, because that'd be loads if we've got 2 years of every single hour. And see if you can see the difference between 2011 and 2012. So give that a go, and then I will open up a poll for you to have a go and answer those questions. Also, just in case, you know, this need a bit of a refresher. Let me just launch that poll. I've given some tips about some methods you might want to use. You don't have to use these methods. There are other ones to use. But for each question, I've given some tips about which ones you might want to have a go at. Remember, our data frame is not called DF, it's called bike. I think it's actually called bikes with an S on the end. So I'll just change that to say bikes with an S. So instead of saying df.info, which won't work because df is not defined, we want to say head, okay, yeah, bikes. Maybe we want to do something like that. Okay, let me give you some time to have a go at that. 4 questions. I can see one person has already submitted their answer. Well done. And if you've submitted your answer, great. Love to see the kind of the enthusiasm and the energy. See if you can improve your code just to make it really readable, or some kind of output that's really readable. Or you can have a look at the answers. Always include the answers in these so you can have a look. Doesn't mean they're the be all and end all, but they're a very good way of doing them. You can uncomment this and you can run it and it will load in some answers for you to have a look at. Okay, so I will just step back, give you that time. If you've got any questions, feel free to put something in the chat. Just while you're doing that, I just remembered I didn't mention, if you're using the binder link, yeah, that's absolutely fine. It may time out after a while if you're not using it. So we're going to take a break around 11 o'clock. It may time out. If that happens, you can just refresh it. If you refresh it completely, it will lose your progress. So you can just refresh the browser. If you load in that link again, it will kind of refresh everything and start from scratch. So if you want to at any point, you can download your notebook by doing file and download, and you can download it as either a Python file or a notebook file or HTML, whichever one you're kind of more familiar with. I would just recommend as a notebook so you can open it again and interact with it. PDF will not work unless you have an add-on installed. So if you get to that stage, you want to download it, that's how you can go ahead and do that. But all the answers are available, so I wouldn't worry too much about if you lose it, if you come back to it and it's lost, don't worry, because all the answers, you can just comment and get the answers from there. Okay, so just waiting for a few answers to come in. So remember to click on submit. I'm hoping everyone's okay and got it open and they're following along. If you haven't got it open, you don't want to, then that's your choice. You don't have to. I'll give you another few minutes, maybe 2 more minutes to submit your answers. and I'll give you a countdown. So if you haven't answered everything, you only answered 1 or 2, just submit anyway, so you can see what you answered. But I'll let you know when that time is. Oh, see a few more answers coming in now. This is great because it makes me know, I know that you're there, and you're with us. And I see these numbers coming in.
Can I ask a question?
Yeah, of course.
When I try to plot, I get an error that I don't have a matplotlib as my default backend.
Okay, so if you're using plots.plots or anything like this, the PLT, you'll want to do import matplotlib.
I have to do that.
You don't actually need it if you do .plot, or you shouldn't need it. Maybe if you're working on an old...
maybe I did something wrong, but...
Yeah, we'll go through the answers and you can maybe see if there's something different. It might be the version of pandas that you're using. You can always check which version you're using.
Yeah, I'm using the binder link, I think.
Okay, well then it shouldn't, then it should work. So we'll drop the answers in the chat so you can copy and paste them into your notebook as well.
Okay, thanks.
Yeah, great question. Okay, right. I can see 7 answers are in the chat, 8 now, 8 answers in the chat. I'm going to give you up until so I'm going to give you 30 more seconds to answer. If you haven't managed to get those answers, then just answer the ones that you've managed to do. Or, you can be a bit cheeky and you can load the answers in and run it from there. But, it's a little bit cheeky. Brilliant. Okay, 10 answers. That's almost. Oh, yeah, perfect. Thank you very much for putting that in the chat. You'll also have to pip install matplotlib, because I don't think I included it, because I don't think we use it that much. Okay, so 10 more seconds then. So again, if you haven't, I don't know if you have to answer 3 and 4 if it's required, but just put anything and hit submit. So 5, 4, 3, 2, and 1. Okay, I will end this poll and we can see what people have said. Okay, so we're saying, okay, first question, how many missing values are there in the data? 0. Okay, can you, if you've done that question, those 13 people who answered that question, can you put your code into the chat? So just copy and paste it, drop it into the chat, and we'll have a look at different ways of doing it, because I'm sure people haven't used the exact same way of doing these things. Oh, look at that, Bram, that's my favorite way of doing this. Lovely. Oh, Mene's in that as well. Oh, that's not the one I want. Oh, we have isNull and isNA. Okay, so by isNull.sum. Yeah, if I run this, then I see there's 0 in every single column. Because I want it my entire data frame and I don't really care about the column level, I could just do this again. I could do .sum one more time, and I get the value of 0. So 0, few. Okay, few because we don't have to worry about it. What about the next one then? We have a little bit of a difference here. The 9 people who said 2011, 01 to 2012, the last one basically, drop that in the chat. What did you do to find that out? So how did you find the minimum max? I think here I said the mean, but you can also change that to min and max. Lovely, okay. Lovely, okay. I'm gonna go ahead and take this first one. Ram, yeah, lovely one, yeah, finding the min that way. Miana, apologies if I'm pronouncing any names wrong. Please feel free to come off mute and shout what your name actually sounds like. And Menno, yeah, perfect. So we can do the min and the max. We have to take the index because that's what we're looking at. Our date time is the index, the min, the max. And we get our timestamps. So we see the first date in 2011, the last date in 2012. I'm sure the people who got those wrong just, maybe didn't see the 2 here. It's very, very kind of particular in that question. You could go a little step further and say, I just want to look at the date and just have a look at the difference here. Oh, I guess that's not actually that, not much nicer, but we just get the date rather than seeing the time as well. But maybe we need to see the time at the end as well. It's up to you which one you think is more suitable for your needs. I think in the answers, I have done that, but I put it in a print statement, so it prints out a little bit differently. The year, what was the year on the most humid? Again, drop your answer in the chat. How did you find the most humid year on average? All these times, these questions are how a stakeholder would ask these questions, not the bits in the brackets. They would say, what's the earliest and latest date in this data? And people go, I don't know, I'm not sure what you mean, because they don't say get the minimum or the maximum. So you need to translate what they're saying to what you need. Same thing here. They might say the average. Well, average is kind of, this is my math teacher background, but average is really any average. They don't really say you need the mean. So you have to translate that and say, okay, I want the mean. But how did people do that one? Okay, lovely. Oh, look at this. This is really nice. So Nicola and Menno put, yeah, group by. So we've taken our bikes, we do a group by. I love how explicit Nicola is, or Nicola, by doing a by equals. You don't have to do that. You can just say, I just want to group by the index. And then because I want it to be the year, I just say, I want to take the year from that index. It's a date time index, so I can access different parts. We'll see that come up again. And then, yeah, I need to, if I'm grouping, I split the data in these groups, I need to aggregate it. So I pull it back together, and I'm aggregating it with the mean. And then final thing is, I need to access the humidity. I mean, I can see it here, but if I'm giving this to a stakeholder, they'll probably be pretty annoyed because they have to do a little bit more hard work. And you usually, do that for them. They have to say, oh, where's the humidity? What does that mean? Does that mean humidity? So instead, we can do, we can put this anywhere. We could do the humidity at the end, like this. We just get the humidity. If we put it in double brackets, we return it still like a data frame, so it looks a little bit nicer. But we can put this at the very beginning. Usually, I would say don't do this, because when we group by, we usually group by a column, not by the index. But because we group by the index, it doesn't matter that we only take this one column in. And it works just the same. But I would put this just before the mean. And then from here, this is my pandas chaining. I put brackets at the very beginning and end. Doesn't matter if you don't do this, because obviously we're copying and pasting. So it's more difficult on multiple lines. I brackets at the beginning and the end, and then I tab in. So it's just easier to read. So we're now kind of looking at sentences a bit more like a paragraph. And yeah, so I put it here. And then final thing is, I wouldn't do this. I saw someone say you could do .hum to get the column. I wouldn't generally do this. It's a bit of an anti-pattern, because if we have a column that's called mean, things start to get a little bit complicated. Am I trying to get the mean of something, or am I just trying to get that column? So I always say, like, let's access that column using the square brackets, that accessor, rather than the dot accessor. Dot access is fine if you're just doing really quick analysis here and there, but it's kind of, you can sometimes lose it and you forget that you've done it, and then it suddenly gets into production and can cause problems down the line. So much nicer way of doing it. And then finally, again, drop your answer in the chat. Which amount of bikes by month, or plot the amount of bikes by month. How does this change between 2011 and 2012? See, most people have put the right things. We see it follows the same seasonal pattern. I would imagine that's true, but we'll have a look. And then 2012 looks higher than 2011. Well, that's pretty good for this company. Sounds like they're improving their sales. The easiest way to do this, you can just plot straight away from a data frame. If you just do bikes.plot. Takes a little while because it's trying to plot all these columns. But you can see that my account, because it's the highest, it's the main thing I can see. But I don't want the rest of these things. So I'm just going to say, right, just after my bikes, I'm just going to say grab just that one column, CMT, and just plot that. And I can see this sort of pattern of, the earlier months and the later months. Not so many rentals, much more in the summer. Same thing happens in 2012. However, I haven't got this by month. So from here, I probably want to do a group by and then do bikes. Index for year. Actually, that's not what I was going to do. That's quite nice because it's different colors. That's actually not what I was supposed to do. I was supposed to do group by month. That's also not what I'm trying to do. What am I trying to do? Extra by month. Oh, because I haven't done my sum. Yeah. Oh, yeah, okay. So here, if we have a look at it, we have it by month, but we probably want to do it also by year because the years are different. So we see straight away, if we just plot this, there is a seasonal pattern throughout both 2011, 2011 and 12, but it's combined. So actually what I want to do, and this is one of my favorite methods ever, is if I group by two things and I put the year afterwards, likes.index.year, I get my month also by the year. I can see the difference here. If I just plot this, it probably won't be very interesting. That's way confusing. What I can do instead, my favorite method is unstack. Well, it's not my favorite. My favorite is about to come up, maybe second favorite. If I unstack it, unstacks it. So I have my columns, my rows, sorry, is my months, but I have two columns for my years. And now if I plot this, I get them on top of each other. And I can see differently. Okay, 2012, definitely higher. They definitely follow that same pattern. Bram, no, you don't need to install matplotlib if you're just doing .plot. .plot is a method that's within pandas. It's from matplotlib, so it builds on the same way that matplotlib works. But you don't need to do it unless you try and then do plots.title or something. You try and affect the plots. But we don't need to do that. We can just do that within here. We can do our title in here and say, what is this like? Total bike rentals. Something like that. It's a bit too long, this whole line. So again, I'm just going to put this on multiple lines here. So I'll do bikes and then group by. Every time I see a new method, I'm going to put that onto a line. I'm also going to put the count actually onto its own line. But every time I see a dot, put it onto a new line. And then I just close off those brackets. Interesting that you did have to use matplotlib. Apologies if you do. Yeah, I would. If you don't have it installed, then I would do what methods we. Let's see if we can find that in the chat again. Just copy this message that Jurgen put in. Yeah. So if you didn't have it, yeah, you can install it. You shouldn't need to. You shouldn't need to in the environment, which is a bit strange. I'll have a look at that afterwards. I'll have a look. It's maybe something to do with the versions, and shame on me for not putting matplotlib in there. Okay. So that's just a little bit of an overview of just really understanding data a little bit more. Again, the answer's a little bit in here with the question. It's just sort of so it outputs a little bit clearer. You can go ahead and run this, but no, it's not important, but we've already covered this in a little bit of detail. Right, I think what we'll do is now that we understand that data, we'll take a short break until 11:05, so you can refresh and come back feeling really good and ready to do some more advanced work. So let's take a little break now, and then we'll come back and do some feature engineering. Okay, so I'll still be around. I'll just turn my camera off. So if you do need me, feel free to message or come off mute. But see you in 7-ish minutes. Okay, right, it said 5 past, so I'll give people time to get back. I do see a question in chat about, in my chain, I'm reusing the bikes variable. I'll just answer that one verbally, because I think it's a bit easier. Yeah, I keep reusing the bikes, and the reason for that is, this is quite a small data set. So doing any of this computation, it's not going to take long. Yeah, I am repeating things. However, I think that's a little, for me, I think that's a little bit better. I don't like creating temporary variables, because by the time, you know, if we create temporary, call this temp df, and we created this here, I mean, this is, we have to remove the plot, because otherwise we're going to create a plot image. But then we have temporary variable here as well, and this becomes temporary df2, and this comes temporary df3. I mean, this is not a data frame, but you might see where I'm going with this. It ends up being temporary 1, 2, 3, final. This is the final one I want to use. So I much prefer this chaining method, and throughout today, we will make some new changes and new data sets, because once we've done all of our cleaning and all of our changes, then we create our data set and put it into the model. But I'd rather much just use my original data and not change it, because I don't have to remember, okay, this was the one that I grouped by the index of the year, because I might end up calling it something like bikes index or group by year, and call it something like that. And then it's like, which one was my variable? It gets a little bit confusing. So I'd much rather use the original data. Once it sort of becomes something that's a really big intermediate step that I need, then I would call it something. But we'll also show you a method with the pipe method, which helps a little bit better, because then you can reuse bits of code like this. You can reuse bits of code just by piping it on, and I'll show you that in the next section. So a really good question, but yeah, like I say, I much prefer just starting with the data from scratch, and I much prefer using the pipe method than creating these temporary ones or overwriting the data itself. That's my big no-no. Never overwrite the original data, because the code should always run the same no matter where you run it in the notebook. If you run some code at the top, if you've done some code at the bottom and you come back to the top, it shouldn't run differently. You might end up, that's kind of functional programming, which I'm quite passionate about.
If I can respond to that.
That's fine, that's how you prefer to work. Yes, was there a question?
Yeah. Can I respond to what you were saying?
Yeah, of course.
I was not really referring to reassigning the chain, but mostly to, for example, in the group by, you are using the bikes variable again. Yeah. However, maybe in your chain, you would add a column or change something in your data frame, and you would like to use the data frame from the last change in your chain. Oh, yeah. In your chain, I mean. For this, usually you can use the lambda as a. Yeah. I'm sure if you're familiar.
Yeah, of course. So if I do something like this, and I just comment this out for now, and I create a variable called year. Yeah. And I want to use that.
Yeah, now you want to use this data frame again, for example, to do your next operations, then to refer to that data frame that comes out at the end of your chain.
Every step in your chain, because it's output, this is output a new data frame. So I haven't, one of my biggest pet peeves is in place. I haven't done anything like in place, so I haven't changed the original data. I have an output. Because I've got an output that's also a data frame, I can just chain another data frame method, like group by. And I can access this year column, because I've created year. I can just access it here. And I can say, right, pick my year column. And then maybe I want to do some of that, and it takes my year column. And yeah, you're absolutely right. Like if I then want to do an assign, maybe instead of this, and maybe I want to use this year column, maybe I want to create another assign that says, is this 2012? And then it takes the year column. I can't just say bikes year. You're absolutely right, that won't work, because bike year isn't in my original data frame. But yeah, then I can use that lambda function and say whatever data frame I'm currently on this line, take that year and say, is it 2012?
Yeah, that is what I was referring to not reuse the bikes variable.
Yeah, exactly. Yeah, perfect. That's a lovely way of getting around it. And that's what we talk about in in a lot of our courses, actually. We bring this back and you'll see it later on. Can you copy this code in this chat? Yeah, of course. Let's copy the whole thing. You may lose some of the indentation. Feel free to. It doesn't really matter because you're in brackets. Doesn't matter if you have it without the indentation, but it looks a little messy, so we don't do that. So I'd just say put the indentation back, highlight it, and hit tab, and we'll indent it for you. Yeah, great question. Thank you so much for bringing that up. I think it's always nice to think about that best practices in coding. And yeah, this is one of my favorite things that you can do, and just refer to the data frame you're currently on. Okay. So now we understand our data. We're really going to get the last hour. We're really going to focus on this topic of feature engineering. We're going to create a baseline model, and we're going to look at our data and process and make some features, and then make a baseline model with those features. Because one of the key important features we have at the moment is the date. The date really tells us a lot about how much, if we use 2011, we can say, actually, we think in the middle, we're going to get more rentals. I want to use that for 2012 predictions, or 2013 and 14. So date's really important, but I can't use date time as it is because scikit-learn doesn't allow us to use date time. So what we can do instead is we can access the year, the month, and the day, and the hour, just like we've seen already, and create some new features for those variables. I'm going to be using, anytime I'm creating something new within this data, I'm changing the data, I'm cleaning data, I'm going to use a pandas pipeline. It's just the same as what we've seen already, just chaining a method, but this time I use the pipe method. And what that allows me to do is something really, really cool. I can create a function. So here I have a function that takes in the data frame, and it gets the date values of the index. Maybe it should say of the index. It gets the date values, and all it does is it says, whatever my data frame is that I feed in, assign, which is going to create new columns. Assign allows me to create new columns. Assign these new columns, year, month, day, and hour. I have to unpack this. It's the dictionary. I have to unpack it so it knows that there's multiple items in here. And then I'm just going to say the year is going to be equal to the index, the year in the index. Again with the month, again with the day, again with the hour. And now that function is prepared for me, it's saved for me to be able to pipe that in. And how do I pipe it? I just take my bikes data frame, I do .pipe, and I just pipe in that function. If I have a function that takes in data frame as its first argument, then I can just use pipe to run that in. Normally what you would see is, you have a function and then you do something like this, and then you put your table in your table in here. But if you then do another function, then you have another new function, and you have to wrap that again, and then you have another new function, and you can see where I'm going. It's getting very complicated to see the steps. Where instead, if I'd say bikes.pipe, and I say function 1, and then do pipe function 2, and then I can just add this on just like a chain. And then also, because I have my chain, I can do my steps one after the other. First pipe, or first function, second function. And now they are reusable steps that I can use multiple times, not just in this data frame, other data frames as well, as long as the index is a datetime index. So that's what I'm going to be using. That's what I'm talking about when I talk about pandas pipelines. So let's do our first one, getting date values. I'm going to pipe this function into here. It doesn't take any other parameters, just that data frame. Data frame is bikes. And it's just going to create these 4 new columns. So let's have a look at what that looks like. Well, I had it up to here originally. Here are my 4 new columns: year, month, day, and hour. Great. So I had those 4 new columns. And I've just created this as a new data frame because this is just the original data frame, my baseline data, to create my first model. So now that I've got that, I'm going to do the scikit-learn steps. A little refresher. If you haven't done this before, you just need a reminder. First thing we need to do is split the data into X and Y. X is our features, our independent features. Y is our target, what we are trying to predict. We need to separate them because if we use the target to predict the target, we're going to be pretty good at it. And we won't actually have the target in our future data. So if I'm trying to predict house prices for next year, I don't have next year's house prices to try and predict that. So I have to make sure I separate that out. Then we encode the features where necessary. Maybe we need to create some dummies. Talk about that when we get to it. We create the train test split. So we're in a time series data set. We're doing time series and we're predicting time series. Our holdout or our test data should always be the end of the data, tail end of the data, because we're using the past to predict the future. We need to kind of say, okay, are we going to be able to predict the future we need to kind of make a decision about where our future data is. So I'm going to use the train test split function, and I'm going to say shuffle equals false, because usually it shuffles it and does it random. I don't want it to be random. I just want it to grab the tail end of the data and have that as the test. Then I'm going to build a model. I'm going to use a pipeline with different stuff piped into it. And I'm going to use a specific model algorithm. We'll come on to that. And then once I've got that model, evaluate it using metrics. In this case, we're just going to use the metrics R². We cover different metrics in another course. This section is really just about the feature engineering. So I'm just going to look at this one metric, but usually I'd want to look at more. But for the purpose of today, that is just fine. So I have my get X and Y. I have the section about one-hot encoding. So if I have some columns, I don't need to fill in any columns. It will just sort of, if there's none there, it won't run this bit of code. If I give it some columns, it's going to take those columns and it's going to get the dummies. You can chain this in, you can use scikit-learn transformers. I haven't used that today because there's something that comes up a bit later where I need to be a bit more in control of my data. I'll talk about that when we get to it. But really, this function is all about just splitting the X so that it drops the target feature in X, but keeps only the target feature in Y. And then we train our model. So again, I'm not going to go into much detail, but you can see the train test split. You can see my pipeline and the different types, the different steps it's taking in. And then you can see it's fitting that model, and then it's evaluating it with predicting on the train and the test, and then scoring the train and the test. So scoring the train, scoring the test, and it's just going to spit out some values to me. So I'm going to go ahead and run that cell. Nothing happens, it's two functions at the moment. And I'm going to initialize these models and then process the data through these models. So I'm going to create a random forest model, a random forest regressor, and I'm going to do a linear regression as well. Linear regression is really good for doing time series. But we're going to compare these two because it's, this is kind of one of the aspects of machine learning. You might not be able to choose your model or algorithm straight away. Doesn't matter, just try both of them out and see which one we prefer. So I'm going to go ahead and run these and instantiate these as my models. Then I'm going to go ahead and split the X and Y. So there's my X, there's my Y. And I'm going to take my process. Look, here's my pipe function again. This isn't actually completely necessary because it's only just one method, but it's nice to see that pipe method again. And I'm going to pipe the X and Y. If I have a look at how X and Y, the get X, Y function works, it spits out both X and Y. So I'm just going to create X and Y from it. Now, because these next functions take in multiple data frames or a data frame and a series, it's one column, I'm going to use the original syntax where I just take my function and I just feed in the parameters. But all I need to say is my X and Y are these, my X and Y, just create them. And then I want to say, do the linear here, do the random forest here. It spits out the model, which I then can use later. But also remember, just prints out some information. So let's go ahead and run this. So our linear regression goes first. We get a train score of 0.39. We get a test score of 0.3. This is our R² metric. It's between 0 and 1, or hopefully it's not negatively correlating. So hopefully it's got some positive power. And 1 really is the best. That's really kind of what we need to know here. So we can see here, the linear regression isn't really performing as well as the random forest, but there is quite a drop off between the train and the test. So we might be thinking, okay, this maybe looks a little bit overfit. So overfitting, if you're not familiar with it, it's just really when we've trained something, we've got some analysis that really looks at the specifics of a particular data set, which means it's not very useful on this test data, some unseen data. So that means actually if we put this into the real world, it will probably lose more performance and not be as good. So this kind of big drop off, it's a little bit concerning to see at the beginning. So both models here could use a bit of improvement. So we're going to engineer some features to see if we can improve this performance. So we'll let you have a go at doing some of these, but have a think in your head. We have these dates. What could be useful to understand? So we're going to add some features based on what we think might be good for additional improvement. So here's 3 things that I think would be really good to add. You can have a think in your head about what other things we could add as well. But is the day a holiday? Mention this at the beginning. Maybe because it's New Year's Eve or New Year's Day, that's really important. So maybe we need to be aware of that. What day of the week is it? Monday, Tuesday? Are bikes more likely to be hired on a Saturday and Sunday because it's personal use? Or are they more likely to be hired on a Monday to Friday because people need to get to work and that's how they get to work? Don't know, let's find that out. Maybe the season makes a difference, which we kind of saw that seasonal trend. Maybe because it's winter, people don't like to hire bikes in winter. So maybe we want to extract the season. So our first exercise is to pull in the holidays. So again, I'm just going to load in a poll, just to see how you do with this. How many holidays are there in the data frame? So how many US holidays are there in the data frame? To do this, well, there's a few ways you can do this. You could go online, you could Google every single date that was a holiday between 2011 and 2012 in the US. However, Pandas is a little bit nicer to us. We have this object or this class of US federal holiday calendar. We can access that out of Pandas. If you go back to the start of the notebook, you'll see where it's pulled in. And if we just access the holidays and we give it a start date and an end date, then we can just access all the different US holidays from there. So have a go at doing that. Have a go at doing our US federal holiday calendar and accessing those holidays, giving it a start. Maybe I could try just doing this year or last year even. And I don't know if it will take in just the years, but let's have a look. Yeah, there we go. And I get just the holidays returned to me. So that's my start and end note. But you need to change this obviously to term, we know what the start date and the end dates are. It's not 2011, it's 2020, it's 2011. And I can see here, all the holidays, that's New Year's Day, that's something like Martin Luther King Day. I'm not going to know all of them, but that must be Thanksgiving and Christmas, of course. And then I also think they have, this must be Independence Day. So have a go at doing that, but change those start dates. Remember how we did them already with using bikes? We could do something like that. That would be much better. And if you need to find out how many you have, well, you could go ahead and count them 1, 2, 3. Or we could just say, what's the length of this list? What's the length of this? So in 2020, there was 11. How many are there for 2011 and 2012? Okay, I can see 2 answers have come in. So let me give you a couple minutes to have a go at that. Okay, this is excellent. 6 people have voted. That's 30%. It's another vote in the chat, in the poll. Let me give you 1 more minute to see if you can get those answers. Okay, 30 more seconds. If you do want to have a guess, you just want to blindly guess, feel free. You might be able to work it out, if there's 11 in 2020. Well, we're talking about 2 years, not just 1 year. Maybe that's a little bit helpful. Strangely, they're all odd numbers that you have to guess. I would imagine that it's an even number because you've got 2 years. Anything times 2 is an even number. So a bit odd that there's 19. I wonder why. It must be an extra holiday in one of these years. I wonder why that is. If anyone knows anything about the US holidays, yeah, let us know. Okay, 10 more seconds. And I will close this out. 5, 4, 3, 2, and 1. Okay, again, if you managed to get the right answer, most people did. 19 is the right answer. So 11, I think you maybe haven't got the beginning and the end date quite correct. You've only got 1 year there. 11's correct if we're just looking at 2020, 2021, but we're not looking at those. So from here, we could put, 2011, 2011, 01, 01, and then what was our last date? 2012, 12, 31, we could put something like that in. And then if we just do the length, we should get our answer. 19, nice. But here, it might be nicer to make this a little bit less static and make it dynamic. Take in the index, the minimum of the index, and maximum of the index. Let's just copy that across. Max. And I get the same thing. And now it's static. If my dates change in that data frame, I can still get the amount. Great. Okay, well done to people who put 19. Maybe the others just a little bit off. I'm thinking maybe you just didn't get the entire year there. Oh, I don't think I shared the results. You can see the results here. Okay, if you didn't manage to do it for whatever reason, you just want to load in the answers, you can do. We're going to create this as holidays. So it's going to be called holidays, capital letters. I quite like using, if this is going to be a global variable that's going to be fed into a function. So I quite like using capitals and global variables, but it's a personal choice, but we need it to be capitals for this notebook because we use it a bit later on. However, it's already loaded in. You don't actually need to run this. I think actually it's already loaded in at the very beginning. You can look back and see how that's done earlier, or you can just run this notebook in the cell. It doesn't really matter. It also says how many holidays there are. Okay, let me stop sharing that poll so I can get it out of my way. So we have some functions here that are going to help us a little bit with those questions. My first question was, is the day a holiday? So I'm going to do an assign, and I'm going to say, is it a holiday? And it is a holiday when the index, the date in the index is in the holidays list that I've just created. And this is a really nice thing. You can do is in, you have to do equals 19 times, if it's equals this, or it's equals this, or it's equal to this. You can do an is in some holidays. We're going to get the weekday. That's really easy. I'm just going to get the day name. You can also do something like weekday, but with that you need to use ISO calendar. It's changed recently. Day name I think is nicer because it gives us the actual names of the day. Weekday will only give us 0 to 6. You have to remember which number correlates to which day. And then the final thing is I'm going to do is get the seasons. Now the seasons, I'm always like, what are the seasons? I mean, at the moment it still feels like maybe just becoming spring. Maybe today is actually really nice, but recently it's really felt like winter. But I'm going to say that these are the months. So December to February, March to May is spring, June to August is summer, and September to November is autumn. So you can see I've got my doc strings giving me information about these functions. And here's my mapping. So if it's, I'm going to just grab the quarter. I'm going to do an offset of 1 month because obviously quarters go from January, February, March, and then April, May, June. And I don't want that. I want it to be offset by 1 month. So I'm going to do an offset, and then I'm going to grab the season using that season mapping. And I'm just going to assign this as a new column called season. And there are my functions. And I can go ahead and I can pipe that. It's a little bit further down. I pipe everything in there. Again, I'm going to give you a chance now to generate your own features, just like we saw above. Give that a go. Okay, so generate your own features. This time, how many weekend days are there in total? So, so the first one, sorry, that's a question to answer, which I'll put in the chat. And then another question, how many work days are there in total? So create a Boolean for, is it a weekday? So I'm going to say get is weekday. Maybe this could be a good function name. And I'm going to return that data frame. I'm going to assign, I'm going to do something like is weekday. And I'm going to grab that index. I'm going to say, is it a weekday? I think I've done it differently in the answers, but we could do day name. And we could do an is in. I'm actually just writing the answer. Let me give you that chance to have a go at it rather than me just writing that out. Where I'm saying, why do we do this? This bit here, it's only because if you uncomment it and you run it, so if I uncomment that and I run it, it loads in a script that's placed that lives elsewhere, it lives in our answers folder, and we get the actual code. I only really use it in training. I don't use it in my analysis. But it's great for just loading in a script. If you go in the answers folder, you'll see the scripts here that we're pulling in. Okay, so let me give you a chance to have a go at some feature generation. Again, I'll load a poll, but I'll just give you like sort of a few minutes to have a go at this. I don't think it matters too much if you don't get the right answers here, because then you have to do a bit of analysis to answer them. Just have a go at writing these functions. And then obviously to run the functions you want to type, get is weekday. If I just say this is a 1, I get my column is weekday, and this is 1. If I want to change this 1 to something else. So I'll drop that into the chat, and you can feel free to copy that and just change what you need to. You need to change this 1 to actually say, you know, this is a weekday. So again, I'll put the poll up. Really, I'll just give you time just to really have a play. Less so much about getting the right answer here, but just really about playing with generating some features. And yeah, if you've got any questions, yeah, feel free to drop them in the chat, so we'll come off mute. Oh, awesome. I can see an answer already in the chat. We have a pandas whiz in the taster today. Someone who's really comfortable doing some pandas. Or someone who's just guessing, maybe. Maybe that's it. If you have finished, it's a chance for you to really be creative. Maybe think about a variable that you want to add in there. You can go as advanced as you want or as simple as you want. And yeah, add a feature in there if you think that you have an interesting feature to add. Maybe you do something about the ratio between the temperature and the humidity, some kind of relationship between those things. Because maybe a combined column will be more telling than just one column. You know, that is extra if you want to have a go. Okay, so 3 minutes has passed. So I hope you had a chance to have a go at that. I'll give you 1.5 more minutes. So just see where you get to. A couple more responses coming into the poll. That's really nice to see. Okay, so I'll just give you 30 more seconds. If you want to really kind of, just see what the answers are, you can feel free to uncomment this, just remove that hash, run it, you get some answers in there, and then you also, if you just run it one more time, it will show you what the answers are at the bottom, so you can see the code. But I would just really try and have a go at this yourself, to give yourself a chance to give this a go. Okay. Right, let's go through a few answers then. So I've just started writing in here, but let me end this poll. If you're just about to answer, quickly answer it now. I'm going to close it in about 5 seconds. Let me end that now, and I'm going to share the results. So we've got a kind of majority going on here. So we think it's 5,014. So those people who put 5,014, you're the majority. Put your answer in the chat, your code, and I'll copy it across. And the same thing for number 2. How many work days are there in total? Most people thought it was around 12,000. Okay, put your answer into the chat. I'll copy it across, and we'll see how you did it. So now I'm going to be doing something with the index. But what do I do next? We'll see if anyone's brave enough. This is a little bit longer code now, so maybe people are feeling a little bit more daunted by the prospect of sharing. Usually in training, what we'll do is we'll share screens, and people will share their screen and show. And I think that's a little bit nicer than copying and pasting. But just in terms of timing, we'll just keep my screen sharing, because we don't want to lose 10 minutes swapping between screens. Okay, it looks like no one's brave enough to take this on. So what I'll say is you can do something like weekday. And I said before that you'll get the numbers between, oh, Bram, yeah, I can see what you're trying to do there. You'll get the numbers between 0 and 6. 0 is a Monday and 6 is a Sunday. So 0 to 4, just like Bram has said. That's what you want to do. You want to try and get 0 to 4. What I'll tell you, Bram, is what you could actually do is, because it's anything less than or equal to 4, you could just do less than or equal to 4, and that will capture your 0. You don't need to worry about it between 0 and 4, because there are no days that are a minus number. So you could just do something like that, and you'll get true and false like that. Miana, you've got one as well. Lovely. Let me copy this one over. So here's one solution you can do. I think it's pretty much the same down here, except it's got an extra print statement just to print the answer below. Let's see what Miana's one was. So it is weekday. Oh, that was, I haven't copied it again. That's just my old code. Let's see. There we go. Okay, so we have bikes. We're doing .pipe. Oh, we're doing .pipe weekday. Love it. You can do .pipe within a function. Of course you can. Yes. And then we do a lambda, and we say, okay, is the weekday lambda, love it, .lock with a lambda. So good, because it's so scalable, and it doesn't matter where you put that. Love this bit of code. And is the weekday in Saturday and Sunday? So this one will be the weekend. So you might want to call this, and then we've got, so weekend equals gets. Okay, then we're then getting the weekends, and then we're doing number of weekends. Brilliant. Okay, so we're getting the weekends day here. So probably want to change the save number of weekend days rather than weekdays, but that's perfect. Lovely. 5,014. Love that bit of code. Really, really nice. Unfortunately, we just don't have that one bit which actually adds the is weekday onto the end, but that's absolutely fine. We answered our question just as we needed to. Below is a way to do it so that we actually assign that as a new column, is weekday. And then the final one, create a Boolean called is workday. Can we find out how many work days there are? Well, quite similarly, we can say, get is workday. I mean, mine are called check. I think either of those are fine. Takes in a data frame, and then we return the data frame with a new column called is workday. I wonder how I did this before. I just want to try and make sure. Okay, yeah, I just did two different things. So is workday equals, and then I'll take my bikes. Well, I won't take bikes. I'm going to take my data frame. I'll take that index, maybe take the weekday, and say if it's a workday, it's got to be less than 4 or less than 5 or less than or equal to 4. Oh, sorry. Let me just. Okay, can you see it now? Perfect. Thank you very much for calling that out. Yes, I think I'd accidentally pressed pause. I'm just going to remove the poll so I can see it a bit better. Okay, so first things first, I can do is workday. This is going to say it's just a weekday, so I'm almost there. What I need to do is this and something else, and the index is in holidays. Now I don't want it to be as in holidays, because if it's in the holidays and I'm saying that's also a weekday, so I want to do the opposite of that. And the way I can do the opposite of that is with the tilde. When I'm on a different keyboard today, so I can't find my tilde. Where is it? Oh, there it is. I can do the tilde here. And I think that's the same what I did down below here. Yeah, perfect. I'm just going to put that in brackets. Now it's a lot of brackets going on with 3 at the end. But if I have ands, which apologies should be an ampersand, I really should have these in brackets, because otherwise I'm going to be comparing this 4 to this entire thing, and that doesn't really make much sense to compare a 4 to this entire filter or entire Boolean mask. And now if I run, I've got my is a workday, and then from there I can do the sum of is workday and find that out. So let's try that. Is workday, just get that one column. I have true and false. Well, true and false really are just zeros and ones. So I do a sum, we'll add up all the trues, and I get to my final answer of 12,346. So very well done to those people who put that. Perfect. Right, let's move forward. Let's actually add these in and see what happens to our model. So I'm just going to ask you to uncomment this out, run it, and then run it one more time. And then what we're going to do down below, here's my checking of it. I'm going to pipe these things into my data that I'm currently on. I'm on my process data. I'm going to pipe in the 3 functions we saw first. Then I want you to add in the new functions here. You can call them, if you create your own functions, put the name of your own functions in here. If not, or if something goes wrong, just copy and paste these ones. Check is weekday, check is workday. Add these in. Let's add another one in below it. Check is workday. And then run that and create our new data frame, right? Date features. And I can see I've got extra columns in now. I have my season, my holiday, is holiday, season, and weekday, and I also have is weekday, is workday. Great. So now that I have that, along with my year, month, day, hour, I can run that through my model. I do exactly the same thing. Retrain the model. I create, first of all, X and Y. Yes, perfect. Now, just because I've created these 2 features, you need to be very careful, because winter and spring and autumn are categorical, they're strings. We can't feed them straight into scikit-learn. Scikit-learn will not have a good time with them. So we need to encode them in some way. We're going to do one hot encoding, which is basically where I, instead of having just season, I have 4 columns called winter, spring, autumn, and summer. And they're either a 1 or a 0 if the original season was winter, spring, autumn, or summer. I could do label encoding, where I just say, oh, I'll just make winter can just be 1, spring can be 2, autumn can be 3, and summer can be 4. However, I want them to be ordinal. No, I don't want them to be ordinal. I don't want them to be ordered. I want them to be separate. And the same thing with weekday. I could do label, because I guess it's a time series. They are kind of related in some way, but for this case, I'm just going to pass them in as one hot encoding. Pass them in there, just when I do my get XY. So I pass in my new data, which is byte date features. I create X and Y, and then I use that new X and Y to create my models. And I just test them. Okay, linear regression hasn't improved. My random forest has improved, but not by much. We have a look at what it was originally, all the way up here, my baseline, It was 71 and 64. Linear model is it's just the same. 71 and 64. And I think it went up by like 0.01. So it's not improved greatly, but it's improved a little bit. Okay, I'll hold my hands up. It's not great, but it has improved a little bit. What this is saying to me is there is some power in giving some new features, but maybe the ones I've created are not really that powerful. And maybe I want to think, is there something else I can do? So I'll just pause there. Like if anyone's got any questions, feel free to ask now. Well, not just now, anytime, obviously. Just let that digest. Either drop something in the chat or come off mute, or just, sit and just think about what we've done. Okay. So I don't see anything coming in, which is, it's fine. Everyone's been asking questions throughout, so you maybe just feel good to move on. Yeah, our next section is going to be creating some features that are a little bit more advanced. So this is a time series data set. Can't we just use the past data to predict the future? So maybe we want to do something like, can we see how many bikes have been rented in the past 12 hours? Because if loads have been rented in the past 12 hours, maybe it's a really hot time for people to get a bike, and that's really telling. Or maybe, in the past 12 days, has business been booming in the last 12 days? And if I'm on an exact hour, at 3 p.m., is that a really hot time in the last 12 days for people to hire a bike? If it is, I want to know about it so I can say, right, 3 p.m. tomorrow, we're going to get loads of bike hires, so we need to be prepared. Maybe we want to do something really similar to this, but we want to say, on a Tuesday at 9 a.m., for the past 12 weeks, how many bikes have I sold? What's the kind of mean number of bikes I've sold over those past 12 weeks? Is that going to tell me kind of next week on Tuesday at 9 a.m. how many bikes I'm going to get? That could be really, really telling. So I'm going to add this in. So features on past behavior, very, very useful. We'll talk a little bit about the caveats after we've done this example. Here's my original data. Well, not original, but what I'm currently working with. I'm just going to keep adding because I'm not doing feature selection right now. I'm just doing generation. So I'm just going to keep adding features in. And I'm just going to use these two functions to add those 3 new features in. Actually, really what I'm doing is one function that then pipes this function in there. So it's really just one function. But I can use this again and again and change my time delta and change how I'm grouping it. Am I grouping it by the week? Like I want to see the past 12 weeks, or am I grouping it by the day, like every hour on the past day? Or I don't need a grouper, I'm just looking at the past hours. And because my data set's already in hours, I don't need to group it by anything. So I can use this same function 3 times, 1, 2, 3. Because my first argument's a data frame, and I have other parameters that go in, I can just feed in my function, and then I can change my parameters as and when I need them. So the new column name is going to be called the last 12 hours, the last 12 days, the last 12 weeks. And these are going to be different time deltas. So the last 12 hours has to be the last 12 hours. The last 12 days has to be last 12 days. Last 12 weeks is 12, because it's 12 weeks. But I need to times it by 7 because 12 times 7 is going to be my entire days. I can't unfortunately do weeks because weeks are not always the same day. So like the first day of the year is not always going to be a Monday or always going to be a Tuesday. It will change. So it's much better to feed this in as days. But instead of working it out, I'm just going to let Python work it out. And then my group is going to be, I want the same hour each time. And this time my group is going to be, I want the same hour and same weekday. So I go ahead and I run this. Oh, and why haven't I haven't? First of all, I need to make sure I run the cell with my functions in. So I'm going to run my functions. Then I'm going to run my bikes in third. Let's just have a little look at my data frame. And have a look at, oh, here they are. Last 12 hours, last 12 days, last 12 weeks. The first 12 instances are always going to be blank because I don't have the last 12 hours. I don't want to sort of say only the last hour, the last 2 hours. But you can see the bottom of my data is filled. And it's looking at this count, which was over here. And it's finding the mean of those last 12 hours, last 12 days, last 12 weeks, and so on. So let's rebuild that model. Just looking at time, we'll just rebuild this model together. I'm just going to code it up. If you want to just load in the answers, oh, you can also see what the model was. An unclear, spoiler alert, I haven't closed off. Maybe the model's going to improve. Let's find out. But let's first of all split X and Y. And let's get X and Y with my data frame, which I've just created. What did I call it? Bikes inferred. It's inferring data about the past. Let's feed that in. Don't forget that we need to do the one-hot encoding because we still have those columns, season and weekday. So they need to be one-hot encoded. Then I'm going to train the models. So I'm going to create a linear model. I'm going to create a random forest. And I'm going to do that by using my train model function that I've got. I'm going to feed in X and Y. I'm going to say this is going to be my linear model. And I'm going to do the same thing here. Train model with X and Y, my new X and Y that I've just created. And this is going to be my forest model. I'm going to go ahead and run that. Again, if you that was a bit too quick, don't worry, you can just comment this and run it, and there is your code. So yes, we have some improvements. My linear model, wow, he's the real star here, or she. Improved from 0.3 and 0.9 to 0.82 and 0.8. And look how similar those scores are now. We've really kind of reduced the overfitting because we've got this new information. It's probably weighting. You can look at feature importance, but that's more for feature selection or just analysis of the model. Probably what's happening here is these new features, these 3 new features are really, really weighted in that model. And it's proving really predictive, and we're allowing ourselves to not be as overfit as we saw before. In our random forest regressor, we also get an improvement. We still have this quite big drop off, so it's a little bit of a concern. It's maybe picking up really kind of particular things about the data set, which random forests tend to do because they're very, very specific and very accurate. So it can pick up some trends that may be a little bit too particular. So maybe something we want to do about that. But we can see straight away that we've really, really improved these 2 models. We're really thriving with these only 3 new features that we create. I mean, we created loads more, but the 3 were we really saw the power. The caveat here is with using past values, we need to make sure that we can always have those past values. Think about the last 12 hours. If I'm predicting for next year, like I'm predicting what's going to happen on this day next year, what is it, the 28th of May? Well, how am I going to know what happened on the 28th of May 2020, 12 hours previous? I'm not going to be able to know. So the caveat there is really thinking about what you're trying to predict, and are you going to be able to have that data? Maybe the last 12 weeks, or maybe the last sort of 8 to 12 weeks, so we go back even further and we just take a proportion of that. It's a bit better because then we can expand the future a little bit further. So caveat is there. Thinking about how we want to predict, we probably want to predict like the next month rather than the next hour, because that's not going to be so super helpful in our bike shop. So just a small caveat just to be aware of. Right. The last one, which I'm just going to briefly touch upon, is mean encoding. So we've done one-hot encoding, which creates dummy features. You can always look at my the X data set and have a look at those dummy features. You can see spring, summer, and winter. You can see they're 1s for winter and 0s for everything else. So that's how that's being generated. But we might not want to do this. We might want to say, actually, for spring, for those seasons, what was the average count that I had? Okay, what was the average count that I had for the spring season in my train data? And then can I use that and map that into my test data? So if I'm saying last year, if that's how my data split with last year and this year, last year I saw in spring that my average count was 1,000. In summer it was 2,000. I just want to map that straight directly across. I can't generate it again because I'm not going to be able to do that in real life. I'm not going to be able to say, in real life, can you generate that from my data? But I can create some kind of mapping from past data. And that's what I'm going to do with mean encoding. So just looking at season, what's the average count for our train data? And then use that in our test. So this is the function that's going to do that. I have to create my X train and my Y train because that's X train is my training data, Y train is where my count is. If I put them back together again, and then I create my aggregates of the mean, that's going to create my mapping. And then I just merge that mapping onto the entire data frame. So whether it was X train or X test, it doesn't matter. It just gets the same mapping that's generated from X train. So any kind of feature generation, if you can't do the same feature generation in your test, because in live you wouldn't have that exact data, you need to do that as well with, because in real life, our data will be in the future, and we won't have the number of bike rentals in the future. It's possibly not possible, or it'll just be an estimate. So instead, we map it from the past. We map it from train, we map it back on. So now if I go ahead and run this, and I'm just going to type in my mean encodings, and I'm going to create bike encodings. And then I'm just going to feed in exactly the same. Now, one thing is that when I've done this, and I've done this get mean encodings, I've actually dropped season as well, because I no longer need season. I actually have season as, rather than it being a categorical feature, I've changed it into a numeric feature because I've got these mean values, I've got these average values. So I can actually drop season altogether. So I now no longer need to one-hot encode it. Thing I will say here is that you can keep it in. You can, and I think I just dropped it at one point here. I've dropped the season column. You can keep it in. However, for linear models, it's not going to be very good. It will weight very strangely, or you'll get confused about the fact that there's two characteristics that are very similar. However, random forest is a bit better for characteristics that are similar, so it wouldn't matter so much for a random forest. So you can keep it in, but for sake of what we're doing, I've removed it. So now if I build that model again, I have a further improvement. Yes. So my train score actually went a little bit down. My test score has gone skyrocketing, which is quite interesting. I'm definitely wanting to look more into this analysis. But my random forest is really where we see a lot of the improvement. That difference between train and test is so much smaller, which means we're definitely fixing that overfitting, making a model that's a lot more general for the future. We probably want to keep testing it maybe on another outer time sample, but we definitely kind of narrowed that gap. And the scores are really much higher for something that's relatively simple to make, relatively simple to look back and get that mapping and add it on. And we've, a little message about overfitting. But we've corrected for that. So some pros and cons about mean encoding. You capture information within the label, so you really get some predictive features in there because you're using the label to predict the label, but you're not using the label as of that time, using it as it was in the past. You can create monotonic relationships between the variable and the target. That's really powerful. However, because it's so powerful, you can lead to overfitting. We saw the opposite, where it kind of corrected for that. Maybe a little bit of overfitting, kind of the opposite, I guess, here, underfitting. But it can cause overfitting because they can be super, super predictive. So it's kind of important to be aware of that. And then the final thing is just to take us to the next section. We might want to look at feature importance. So I'm taking this random forest, and I'm just looking at the feature importances of all those columns. And I can see actually, when I look at it, quite expectedly, these ones that I created to start off with, where I didn't improve the model, they're not very highly weighted. So they're not really that predictive. Where my top 10 or 11, where I can see bars, maybe I just want to create a model with just those top 10. And that's actually a bit better. It's a more simple model. And if I've got fewer features, then I don't have to worry so much about what happens if that feature gets turned off. And I no longer have access to that feature. That data input no longer is a thing. So this might be our next step, which was where we'd go to in the training. That's where we'd go to next, which feature selection. Different types of feature engineering, like I said, this isn't an exhaustive list. However, we've done a few things like this, like time, date features, group the values into something like season, something like sparse classes. So if we had something like a bike type, we'd probably want race, road, and grammar feats to be in its own section, its own group. But something like penny farthing, unicycle, or tricycle, not many people rent those, unfortunately. That'd be so cool if they did. But they might just go into a single other category, so something like that. And then there's a few other things. Like I say, it's not an exhaustive list, but have a look at what we've got there, have a look at what we've done, and see what you can apply to your own data. A few other things, you might want to add external data. So data that we didn't actually have in our data set, maybe something like the general sentiment of bikes at the moment. Like COVID has really improved people's want for bikes. My boyfriend has been trying to buy a bike for a year, and he's got this one bike that he wants to buy. It's never in stock because everyone always keeps lapping it up, keeps grabbing it as soon as it's in stock. And then we've already talked a little bit about this, but can we use them in practice? So if we use something like what happened 10 minutes ago, maybe we're not going to be able to use that in practice because we're only going to be predicting 10 minutes in the future. Which, if you've seen the San Andreas film, I know we're coming up to the end, this is a really important point. That San Andreas film where they predict earthquakes, they only predict earthquakes like in the next 30 seconds. So it's not very helpful. It's like, oh, there's an earthquake. And like, when? It's in 30 seconds time. It's like, well, how are you going to evacuate the entire city if you only know about it in 30 seconds? Great film though, The Rock lives up to The Rock standard, obviously. So bringing it all together, and I'll stick around for questions if you want to hang on, ask some questions, or feel free to email me. Feature engineering is typically time consuming, but can be greatly beneficial to model performance. You only create features that you have available, like we've mentioned. You typically require domain knowledge. That's why that bit at the start where we understood the data, we explored it, it's really super important. So you may be thinking, great, that was a great 2 hours. If we are thinking it's a great 2 hours, I've had good fun seeing what you guys have come up with and what you put in the chat and stuff. But you might be thinking, what do I do next? Well, in the training, we go on to do something like feature selection, object-oriented programming to make your own estimators and transformers. And we talked about advanced Python, that's also included. But what about now? What do you do now after this taster? Well, our next course is happening at the end of June. So if you want to, there's a link here, takes you through to signing up. I'd love to see you in that course. We have some other courses. Maybe you want to do some stuff around just pandas. So Python for data analysts, maybe where you want to explore pandas. Maybe you want to go back a bit and actually learn the machine learning algorithms that this course is based on. So you go there. And there's more. Like I say, we really branch out into really specific advanced work. And also you can download our training guide if you really want to know all the training that we have available. A couple of things to download the notebook. So if you're in, maybe I should open this one. Oh, my binder is unfortunately collapsed, but you can click the download button at the top, which will download the file as an IPython notebook. You can also download it as HTML if you don't want an interactive file, but you just want to have a look at what you've done. You can visit the repo at the top of the page. This one is here, visit repository, and it will take you through to the repository where you can just download everything as a zip file. But that brings us to the end of the training. I'm sorry we went over by 2 minutes. I just think I got a bit carried away with how great everyone was doing and how much we were getting done. I really hope to see you in future trainings. If not, really good luck with your data science work. And yeah, start generating some features and see what you can do. I'll stick around for like 5–10 minutes if anyone's got any questions. Thank you so much for your message in the chat. I'm glad you enjoyed it. My email, I'm just dropping that in the chat. Feel free to reach out with anything. Someone reached out the other day and just sent me a piece of code and said, can you have a look at this? And I said, yeah, of course. It was so much fun. So please feel free to reach out. And yes, I hope to see you in our future trainings. Lovely. Thank you so much, everyone. Have a great Friday. Last bit was a little fast. Yes, sorry, Ronaldo. It's a little bit fast because of the timing. That's my fault. Apologies. But yeah, have a lovely Friday. Have a lovely weekend. I'm so happy to hear how much you learned. So have a lovely rest of the day. Cool. What do you think about using a tool like Azure Machine Learning as opposed to coding everything? It's not a tool that I have experience with. So I don't want to say too much about what it's like. What I would say is I much prefer, so this might be a personal thing, but I much prefer coding because you can be very specific about what you need. So if I have a look at how I've done this, I've been very particular about what goes into my data frame, my machine learning model and what comes out. I'm very much in control. Maybe this is something that I really need to be in control of things. And you can package your production in Python in a really nice way. You can add it and have it on GitHub. It's very collaborative. I'm not sure how Azure machine learning looks like. It kind of sounds like it might be like more like a kind of point-click wizard type of thing. Correct me if I'm wrong. But yeah, I much prefer having the coding knowledge behind it.
Yeah. Can you hear me, Lucy?
Yeah, I can hear you.
Oh, okay, yeah, okay. I understand your answer. I'm actually not a data scientist, so for me, it works a little bit better. But if you're very good at your job, like you obviously are, I can understand that coding everything gives you more flexibility.
Yeah, I think that's the biggest benefit, and the collaborative approach as well is a huge benefit. But yeah, like I think if you're not a data scientist, you're not a coder, then really the key thing is, if you're using a tool like that, is really just understanding the algorithms and your data as much as possible, and being a really kind of domain expert.
Yeah.
So that you can, because it's very much, it'll be very much kind of in a black box if you kind of put it in something and you get an output. So if you understand kind of what's going in, you understand what's coming out, then I don't see a problem with it. Not having that flexibility isn't an issue. So it's really just understanding the what goes around it, really.
Yeah. Okay. Thanks, Lucy. I thought it was very good. Very good. Thanks.
Good. I'm glad to hear. Yeah. Good to have you.
Yeah.
Okay, so a few people still left in the chat. I'm going to close out this training in kind of just a few minutes. So if you do have a question, speak now or forever hold your peace, or you can drop off. Enjoy. Hopefully your weather is just as nice as it is here in the Netherlands. You can enjoy that.
Thanks, Lucy. I'll see you later.
Yeah, see you later.
Bye-bye.
Bye. Any comments on profit? Whoa, yeah, profit. So we have a course on time series in general, which looks at profit. I think it's a great library. It's so powerful. It's amazing. It can pick up stuff like holidays. It can pick up different trends, breaks in trends. It's like kind of like magic. I don't know if you've used it, if that's maybe why you're bringing it up. But yeah, you kind of plug in your data and it really just spits out this really powerful model, and it's kind of, colleagues have used it. Yeah, so it's super powerful. The only thing I would say about it is it's very much of a black box because it's so powerful and so much going on inside of it. However, like where I've seen it used, and I actually was speaking to someone about this the other day, they use it for, they're predicting, I think they work at a supermarket, so they're predicting something like sales or something like how a marketing program will affect sales. And they only use it for a very specific portion where they don't have enough data to build something like what we've seen today. So it can be really powerful, and something like that, I can see the use case so much. I haven't heard of anyone actually just using profit and just relying on that completely. But it might be something that, yeah, that you might want to do. It's like I say, it's a very powerful library. And I maybe just get a link. There's a really good documentation for it, or a good paper. And yeah, if you're interested in it, I would go through it with, first of all, there's the documentation, and it goes through how to install, how to do something, and a really good tutorial. I would just go through that and see if you can do it on your own machine. And then there's also a really good paper on it, which talks about not only the library and how it works, but also maybe the benefits, but also the limitations of it, or the cons and stuff like that, which I've just linked again in the chat. Great. Hope that answers your question, Scott. Perfect. Oh yeah, and if you are interested, Scott, here's the link to the practical time series analysis and forecasting training that we run, and it's like it's own topic in its own right. It really is. It's so much interesting things with time series that you have to respect and give it the respect it deserves. Okay, well, I'm going to close out this taster. It was lovely to have you, so Scott and Aditya. So I'm going to close it out. If you've got any questions, feel free to message or to email. Hope you have a lovely weekend, lovely rest of your day, and hope to see you soon.